Hello! Today I am going to be teaching you about orbits and what makes orbits happen, and it has to do with gravity and inertia. So we're going to make a little model. So first, gather some supplies, and you might want to pause this video while you gather the supplies. So here's what you need. You will need a piece of construction paper, preferably dark. This represents space. You are going to, I used a piece of cardstock, but you could just use a plain piece of white paper if you'd like. You're going to need 2 arrows. I printed these out for everybody, but you can just draw them. It doesn't really matter. But you'll need 2 arrows. You will need a compass so that you can draw circles, unless you're not picky about how circular your planets are. You're going to need some colored pencils, especially you're going to need a light colored one to draw on your dark background. You'll need a glue stick or tape, and a pair of scissors. So, and of course something to write with. So that's what you'll need. So go ahead and hit pause and go gather your supplies, and then we'll continue. All right. The idea with the model that we're making is that we are going to kind of show how a planet would interact with our sun. So we're going to draw one big circle and one little circle. And so I'm going to go ahead and draw a big circle, and that represents the sun. And then one little circle, and that represents the planet that goes next to the sun. Now you're going to want to color these in and make them look nice, because we're making a poster out of this. And so the nice thing is, if you color it in before you take it off the paper, you can color outside the lines because you're going to cut around the circle. And the other nice thing is, with something like the sun, it's just a swirling mass of gases, so you don't have to make it look all perfect or beautiful or anything, because it's a swirling mass of gases and plasma. So you're going to do a bunch of that sort of stuff, and I am not going to make you watch while I prepare, but you can go ahead and get yours colored and then continue the video once these are cut out. All right, now you should have a sun and a planet cut out and colored. Okay, and set those aside. Now we've got our 2 arrows. On one of the arrows, I want you to write the word gravity. Nice and big. And then on the other arrow, go ahead and turn it upside down so it's facing the other way. And you're going to write the word inertia. Inertia. And those are going to be the 2 forces that we're talking about that affect an orbit. So you can color these if you want, because we are making a poster, but you do need to cut them out. So I'm going to pause my video once more and cut these out so that we have something to look at. So now you should have a sun, a planet, an arrow that says inertia, and an arrow that says gravity. Now, if you would like to decorate the front side of your background to look like space, you can do that. I did. But right now what we're going to do is flip this over to the back side, and here's where we're going to talk about what actually happens. So planets orbit a larger body like the sun because of one thing, and that is gravity. So Sir Isaac Newton did a whole bunch of really cool things about science, but one of the main things he's famous for is his law of universal gravitation. And what that said is that every object in the universe has gravity, and every object attracts every other object. So we're going to go ahead and write that. Every object in the universe attracts every other object. And what this means is that we all have at least a little bit of influence. And what Newton found, and other people since then, is that the bigger you are, the more gravity you have. But also the closer you are to something, the more influence it has. So while we have our own gravity, the Earth is so close to us and it's so much bigger than we are that it actually has a lot more influence than we do, so you don't really notice our gravity. But if we were out by ourselves in space, smaller objects might even orbit us. If you took dropped a screwdriver out there, or even just little dust particles would probably orbit you because you would be the biggest object out there. So that's kind of a cool thought. But right now, we're way more affected by the Earth's gravity than the sun's gravity. Even though the sun has way more gravity than the Earth, it's 1,000,000 times bigger than the Earth. But the Earth is so much closer to where we are that it affects us a lot more than the sun's gravity. So we'll finish writing this, sorry. So every object in the universe attracts every other object. And the bigger something is, the more gravity it has. So the thing with the most mass in our solar system is our sun. And so that's what everything else orbits. Now the other thing we're looking at is inertia. So inertia is a property that all matter in the universe has a tendency to resist change. Everything resists change. So if an object is moving, it doesn't want to stop moving. And if an object is at rest, then it wants to stay at rest. So we're just going to say objects resist change. And then we're going to say rest stays at rest, and moving keeps moving. So once again, the bigger an object is, the more inertia it has. Now, one of the things I like to do to remind myself what inertia is inertia is like a teenager in the morning. So a teenager in the morning is an object at rest. This is an object that wants to stay at rest unless acted upon by an outside force. That outside force is usually called mom, and mom is going to come in and make you get up. So teenager in the morning represents inertia. Now, inertia is what's going to want everything to keep moving. So all of the objects in the solar system are moving, all of the planets and moons and things, and they're moving because of inertia, but inertia is pulling them out, and they want to keep traveling off into the distance. But gravity fights against inertia, and so it holds it in. Between the two of them, it creates what's called an orbit. And an orbit we could just think of as balance. So we're going to write the word balance really big. And what that means is the inertia of that object and the gravity being pulled upon by the sun are balanced, and so that causes it to just go around in a nice balanced orbit. So the official meaning for an orbit is one object circles another. All right, so that's what you need on the back of your sheet. Gravity plus inertia equals an orbit. All right, then on the other side, this is where we're going to make our poster. But first, let's just demonstrate this. So here's the sun, and here's our planet. So the planet's wanting to move outward all the time. That's inertia, okay? But the sun is pulling it inward all the time. And so between the two of them, it just goes around and around and around. And as long as it stays balanced and nothing changes, that's going to just go on and on forever. So the way that we're going to make this poster is we'll glue the sun up here. And the sun represents the source of gravity in our solar system, and so we're going to put a big arrow pointing toward the middle of the sun, and that's gravity. And then our planet represents all of our different planets that are moving and wanting to move outward, and so that inertia is going to be going outward. And so go ahead and glue everything down, and your finished poster should look something like this. This is another one I made. And so the gravity is going in toward the sun, inertia is moving away from the sun. An orbit equals balance. So let's write that on our poster. And that is that. Thank you very much. See you next time.